Okay students, so we have already done till question number 3, right? So we'll move to question number 4. So the figure 2.7 is this one. Okay, show a relationship between the set P and Q. So between this, they have given in the arrow diagram what is the 5 is related to 3, 6 is related to 4, 7 is related to 5, right? It's given here. Okay, show a relationship between this and this. Write this relation in set builder form. Okay, so this shows the relation they have said. So you have to write this relation in set builder form and in roster form. Then again you have to write what is its domain and range. Domain and range you already got it, right? Domains means all elements which is having image is called domain. Set of all elements which is having image. So you can see 5 is having image, 6, 7 is having. So all these elements in a set you write down, that will be your domain. Okay, range, you know, the images are called range, collection of images. So 3, 4, 5 will be your range. Okay, so range and domain not a problem. Now see here in set builder form how to write down this. Now set builder form means what I told you, right? We don't write all the elements, we used to write down the property of elements, so that with the help of that property I can write down what are the elements. Okay, so roster form means we used to write down all the elements here. Okay, so in relation set, first thing we know that elements are order pair. So here also all elements, whatever number of elements will be there, all will be ordered pair. Okay, so what are the pairs? That too we can easily write down, right? In roster form you can see 5 is related to 3. Let me write down roster form first. Okay, next 6 is related to 4. Okay, next 7 is related to 5. Only 3 element it will have, right? So relation set, you can see only 3 element you will have. So this is in roster form where we have written all the elements. Okay, now in set builder form what I have to do? I have to write, remember in set builder form how we used to write down when we have discussed in previous classes. When we write set builder form a set, we used to write the elements as X. Now this element we used to write the property. Okay, we used to write one property here. With the help of this property I can write all the elements. What are the elements here? I can easily write down in roster form. Okay, so you have to write down the property in that way there, right? So same way here also. Here the element will be this form, right? I will write in general form. So how I will write? X comma Y here. Okay, so this will be general form, that is your set builder form. Okay, so right now I have to mention what relation is there between X and Y. You know X is 5, 6 and 7 here, right? And what is Y? Y is 3, 4, 5. Now if you see well, I have to write here one property. With the help of this I must be able to write down this one also, right? So you can see I will write down one property here, that is relation here between these two elements, such that you can write down this one. Now see here, for that what I will do, I will try to find out pattern here. Now you can see 5 is related to 3 here, 6 is related to 4, 7 is related to 5. Now you try to see, is there any pattern which it is following? You can see this is 5, this is 3, that is 2 less than this one, right? This is 6, this is 4, this is also 2 less than this. 7, 5, this is also 2 less than this. So can I make that relation only? All this element you can see what it is, 2 less than this, 2 less than this, 2 less than this. So can I write relation between these two? X, this is your X, this is your Y. Okay, let me write down here. This is your X, first element is from this set, right? X, this is your Y. So what I can write? Relation X is equal to, this is equal to Y plus 2, or you can write like this also, Y this is equal to X minus 2. This is 2 less than this, right? 2 less than this X. Okay, in this way also you can write down, or you can write X is equal to 3 plus 2, that is Y plus 2. You can see if I write this property with the help of this, I can easily write down this. But the problem here is you have to mention X. I cannot take randomly anything, right? I have to take X either 5 or 6 or 7. So you have to mention here X belongs to P. The moment I will write X belongs to P, I will take X only value from P. So 5 I will take X, 6 I will take, 7 I will take. Okay, next y, what we will take, y belongs to q. So y I will take only from q. So how I will take, so see here, x when I take 5, what will be your y? To bring this side, 5 minus 2, y will be 3. So you can see this is related. If I take 6, I will get this one. See here, 6 if I take, to bring this side, 6 minus 2, y you will get 4. You can see this is, so x and y are related like this. Okay, so this is the relation between x and y. So you can see I have not written any element here. I have written simply the property of the element. With the help of this property, I can easily get the roster form also. Okay, so in set builder form, remember you need to write one property such that you can get the elements in roster form. So you have to write in that form only. Okay, so I hope it's clear. So next is domain and range you have to find, right? So domain, you can simply write down domain what it is, 5, 6, 7. Okay, this is your domain. What is your range? Range will be 3, 4, 5. So this will be the element of range. If they ask codomain, what will be codomain? Codomain will be all this set, means this one only. Okay, same, Q set will be a codomain. Okay, next question number 5. I have written all this in format so that I can finish it in short interval of time. Okay, I want to finish this exercise by today itself. So you can see question number 5, what it is. Let A is equal to this. So set is given, right? Let R be the relation on A. So this time also relation they have defined on only one set. So that's why when they define only on one set means what? Both set is same. In relation, remember 2 set minimum you will need. Okay, so when they define on only one set, remember they try to imply that both the sets are same. Okay, so define on A, right? Defined by this relation. So relation is given, you can see. So I have already written here R is equal to A comma B. This is the element of relation set, right? Always order pair. And what is the relation between them? You can see AB belongs from A only. A belongs to this set, B belongs to this set, means A only. This is simple, right? Now see the relation between these two elements. B is exactly divisible by A. Okay, B is exactly divisible by A means what? This element, when you write down this one in the roster form, this second element must be exactly divisible by first. Okay, now first thing, what do you mean by exactly divisible? When I say 6, is it exactly divisible by 2? Yes. Why? Because here the remainder will be 0. Okay, exactly divisible means when you divide, your quotient should be first thing whole number, and if the remainder is 0, then it is said to be exactly divisible. So what they have said, B is exactly divisible by A, means this must be divisor here and this must be dividend, right? And this dividend must be exactly divisible by divisor, means remainder, when you divide this by this, remainder must be 0. Okay, so such kind of element only will be there in the relation set. So how I can write down this one in roster? So for first question they have asked you to write down in this relation is given, and they have asked you to write R in roster form. So this set only I will write in roster form. So see here carefully, A will be from this set, B will be from this set. Okay, and these two have relation. What is the relation? This element must be exactly divisible by this. You cannot write randomly all ordered pair here. Okay, you have to write only those order pair in which second element must be exactly divisible by first. Okay, so I will take element from this set first. So 1, if I take 1 here, 1, is it exactly divisible by 1? Obviously yes. 1, this 1 is exactly divisible by this one or not? Yes, obviously, means this will be divisor, right? This will be divisor, this will be dividend. So I can easily say like this also, this if divide this one, then this will be this, and this will be element of R. This if it divide this one. See how I am saying, according to question they have said B should be exactly divisible by this one, means this should be dividend, this should be divisor, right? So how I will check? I will take one element for here and I will check that this divide element from here also only. Okay, this will be your divisor, this will be your dividend, remember. So 1 divide which element? Obviously 1. So 1 will be related to 1. Why? Because you can see this is exactly divisible by this. Okay, next 1, can it divide 2? Yes, of course it can divide 2 also. You can see 2 is exactly divisible. If you divide 2 by 1, what you will get? 2 time 1 time 2 or 2, 0 remainder means exactly divisible. Okay, next, so this is related to this also. So what about 1 and 3? Obviously they also will be related because 3 is exactly divisible by 1. What about this one? Yes, yes. So 1 2, 1 3, 1 4, 1 6, all this will be there, right? So done. Next 2 1, will they be related? Obviously no, because 2 cannot divide 1. Okay, so 2 and 1 are not related. Next 2 2, yes. What about 2 3? No, 2 3 will not 3 will not be exactly divisible by 2, right? So will not be related. 2 4, yes. I hope you can understand all possibility. You have to check. If you have confusion here, what you can do is you find out A cross A first. If you have confusion, okay, A cross A, you write down all the possibility. From there you select those element which will be satisfying this relation. What is the relation? Second element must be exactly divisible by first. From there you can select and write down element. Okay, now I'm not writing this one directly, I will find out from here only. So 2 3 will not be satisfying this relation, right? Because 3 is not divisible by 2. 4, is it divisible? Yes. So 2 4 will be there. 6, yes. 6 will be divisible by 2, right? So 2 6, 2 4, it will become dirty. So I will not draw arrow diagram here. Okay. So 3 1, no, 3 2. So I hope you have already got the idea. So 3 3 will be the element here, because 3 is exactly divisible by 3. What about 3 4? No. 3 6, yes. Okay. 4, now here some student might get confused. 4 2 is not satisfying this relation. Why? Because you can see 4, can you divide with this one? Obviously by taking decimal you can get. Exactly divisible does not mean you have to take decimal. It should be whole number, I told you. Okay, so you will never get remainder 0 here, because 2 is not divisible by 4. Okay, so try to understand this. So 4 2 will not be there. What about 4 3? No. 4 4, yes. 4 4 will be there. Okay, next 4 6, no. What about 6 1? No. 6 6 only will be the last element. Okay, so this will be your roster form. Okay, so from here easily you can write down what is the domain. Domain will be all this element. Okay, all this element means, so don't repeat the element here. So 1 will have image, right? So 1 will be there, 2 will be there, collection of all first element of relation set. So first element is what? 1 1. So 1 1 we are not going to repeat, right? Because in set we don't repeat element. Okay, so 1, the next first element you see 2, next 3 will be there, next 4 will be there, next 6 will be there. So basically domain is your whole A set. Okay, what about range? Range will be, all will be your image, right? So you can see second element 1 2 3 4 6, rest is all repeated 2 4, so don't repeat all those. So 1 2 3 4 6 means your range is also. Okay, next question number 6, right? So what it says in 6, question number 6, you can see where it is. Determine the domain and range of the relation. So this time also you have to find domain and range, but see here relation they have given in different format. So they have just written in a different format this time. So they have given this one, I will write directly here. Okay, so relation set is given like this. First element is x, second element you can see x plus 5 they have given. Okay, now next they have said such that x belongs to this set. So x belongs to this set means what? In the relation set x I will take only 0 or 1 or 2 or 3 or 4 or 5. Only this value I will take here. Okay, and then we'll find out what will be the second element. If I take x0, what will be y? This you can take it as, this is something like this. Can you tell me whether relation is given or not here? Obviously it is given. Relation itself is given in the ordered pair. What is the relation here between this element and this element? The relation is, if you take this one as y, you can write like this. Y is equal to x plus 5, right? Y is equal to x plus 5. So this is the relation between x and y. You can see this is your x, this is your y, this whole thing is your y. So the relation between x and y, this equation itself, I told you it's a relation. Okay, so between x and y, this is the relation. Okay, so instead of writing here y and then separately mentioning relation x plus y like this, so they have what they have done, in place of y only they have written x plus 5. So relation itself is defined here only. Okay, so try to analyze all these things, sit and try to think over all this. Okay, try to understand carefully. This is same thing which we are discussing from the beginning. Okay, relation we have discussed, right? Same thing, it is that one only. Okay, but the thing is they have written this one in a different format just to make you confused only. Okay, so if you have proper concept, then you will simply understand this one, and I believe that you have already understood this. Okay, so in this relation set, we know ordered pair only will be the right. So they have said to write down this one in the roster form. Domain and range they have asked you to find. So what we will do, we will first write down this one in a roster form. Once we will write down in a roster form, there I can write down element in ordered pair. The collection of all, first element will be your domain, second element will be your range. Okay, so first I will try to write down this one in a roster form. So see here how I will write down. So x, what I can take, x belongs to, they have said this set. So x I will take first 0. So if I take 0, what will be your y? 0 plus 5, that is 5 only. So you can see 5 and 0 is related by this relation. Okay, if you have confusion, then think like this, y is equal to x plus, this I can redefine like this. See here, I will redefine this one. This is your rough. Okay, this I can redefine like this. I can write like this, x comma y, where x and y is related like this, such that y is equal to x plus 5, where x belongs to 0, 1, 2, 3. Now about y they didn't say it. Y belongs to what? They didn't say anything. So y can be anything. Okay, it can be any real number. X should be only between these values. So this is how we can redefine this one. Same thing. Okay, so 0 comma 5. Next, if I take x1, what will be your next element? X1, this will be 6. Next, x2, y will be 7. x3, 8. 4, 9, right? 5, 10. So this will be the element. Why? Because 5 is the last element, right? 5 only I can take till hex. Now some student might have confusion in this one. See here, y is 6 also, 7 also, 8 also, 9 also, 10 also. Why? Because they didn't mention y belongs to what. They have just said they have given restriction only for x. X should belongs to this one, that is 0, 1, 2, 3, 4, 5 only x you have to take. Okay, but y, what it will be, they didn't say anything. So this can be any value, any real number. So if I have to draw the arrow diagram for this one, let me draw here only. Okay, if I have to draw an arrow diagram, how it will be? It will be like this, 0, 1, 2, 3, 4, 5, because first element you will take from here only, right? Now second element, what it will be? It can be anything, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till infinite. It will be set of real number actually. Okay, because they didn't mention what is this set, second set. So 0 is related to 5 here like this, it will go. 1 is related to 6, then 2 will related to 7 like this. Okay, because y they didn't say what it will be the element of y. So when they don't mention, we understand that it is a set of real numbers. Same goes with x also. If they don't give this one, we will understand that x belongs to real number. Okay, so from this domain you can easily write 0, 1, 2, 3, 4, 5. Okay, what about range? 5, 6, 7, 8, 9, 10. Okay, these are your range. Next, question number 7. 7 also same, they have given this relation and they have asked, I guess, roster form only. Let me see. Question number 7, write the relation this in roster form. Yes, so this also you have to write in roster form. This time also they have given relation directly here. This you can redefine like this, r is equal to x comma y, where x and y, how it is related, y is equal to, I can write x cube. This is how they are related to each other. Okay, with 1 I can get the other. If I take one value here, I can get the other. Why? Because they are related. Okay, this is how I can relate here. Now x, this time also this is relation is given. Now they have said x is a prime number less than 10. So this time also for x there is a restriction. X will be what? It's a prime number less than 10. So when you write roster form, what number will come first? Your first prime number is 2. You know what is prime number, right? Prime number are those number which have how many factors? 2 factors. Exactly 2 factor must be there. Now some of you might be thinking that 1 is also a prime number. No, it's not a prime number. Why? It has how many factor? Only one factor. Where factor means what? The number which divides exactly. That is called factor. Okay. So 1 is divided by what number? Only 1. Can you tell any other number which will divide 1? Obviously you will not get. Okay, so it has only one factor, that's why it's not a prime number. What about 2? 2 can be divided by 1 and 2 only. So only 2 factor. You cannot find any number which will divide 2 other than this. So exactly 2 factor, right? That's why 2 is a prime number. Next, what will be a prime number next? Next will be 3. 3 also divided by only 1 and 3. That's why it's a prime number. Next, what it will be? 5. You know that. Next will be 7. After that 11, but 11 I cannot take. Why? Because they have said x is prime number less than 10. Okay, so 2, 3, 5, 7 only. So if this is 2, this will be how much? 2 cube. That is, I can write here 2 cube, or you can write directly 8 here. Okay, this will be 3 cube, that is 27. 5 cube, that is 125. Okay, and then 7 cube, 343. Okay, so this time also you can see for x there is a restriction. It should be prime number less than 10, right? But for y they don't have any restriction. This, how much it should be? X cube should be how much? They didn't say anything, so it can be any real number. So that's why whatever I'm getting here I have written that one. 343, 125, 27. Okay, so this is roster form. Next, question number 8. So in question number 8, let a, b is given, find the number of relation from a to b. So very simple, number of relation I have already explained you, right, how to find out. A cross b, first thing, how many element it will have? A cross b, number of element in a into number of element in b. So 3 into 2, that is 6 element it will have, right? Now how many subset it will have? I told you, right, the number of relation is equal to number of subsets in A cross B. Or instead of writing this, I have already given you, right, what it is. Number of relation is equal to how much? 2 to the power number of, directly I will write, subset in A cross B. Okay, number of elements, sorry, I have written subset here also, element in A cross B. This is how we used to find out number of subset. How many number of subset it will have? 2 to the power 6, right? So this is how I can find out here also. So 2 to the power, how many number of elements are there? 6. So 2 to the power 6 number of relations. So you can leave your answer here, no need to solve this one. Okay, next, question number 9, the last question, which is very interesting in the sense you can also do it, but you need to understand carefully here. Same logic we will use. See here. So in question number 9, what they have said is, they have asked you, let R be the relation on Z. So this time also they have mentioned only one set. And what is Z? Z is set of integers. Okay, so this is set of integer, this is set of integer I have written. So whenever they define relation in only one set, then remember both set will be same. Okay, so relation is defined here. Now what is the relation they have defined? See carefully. They have said relation is defined by AB. This is the element where AB is related how? A minus B is an integer. Means if you subtract these two, it should be integer. Those element only must be there in the relation set, in which first and second element, if I subtract, it must be integer. Okay, So find the domain and range they have said. So for domain and range, first thing I have to find what are the elements of this one, right? Now see here, in roster form it is impossible to write down all elements, so you have to use your logic here. Okay, so see carefully what they have said. I will write down the relation here, relation AB, where A comma B belongs to Z, they have said, right? So first element belongs to this, second element belongs to this, so that's what we have written. Next relation, what they have given, the relation between these two elements is A minus B should be integer, means it should also belongs to Z. So this is how I can write down, right? So A minus B, if it belongs to integer, means second element and first element, if I subtract, and if it is integer, then I will include that one in this set. Okay, so in this set, those order pair only will be there in which subtracting the pair will give you integer only. Okay, so you see here from the arrow diagram only I will find out. 0 if I take, these are integer, right? The integers, I hope all of you know. 0, 1, 2, 3, infinite, minus 1, minus 2, minus 3, till infinite it will go. Here also 0, 1, 2, 3, infinite, minus 1, minus 2, minus 3, till infinite it will go. Okay, now see carefully, they have said what? A and A minus B should be integer. So see here, if I take 0 first, I want to find image of this. A 0 minus any element used. Let me take this one first. 0 minus 0 will be there or not? Obviously yes. 0 minus 0 is how much? 0, it's an integer, right? So it will be the element of relation. What about 0 minus minus 1? 0 minus minus 1 is how much? Plus 1, that is 1 only, right? Which is integer. So 0 minus 1 also will be there. Okay, what about 0 minus 2? This also will be integer. You try to subtract, this also will be integer. So this also will be integer, this also will be integer, this. So 0 will be related to all the elements here. Okay, what about 1 then? So those elements, all infinite element will be here. I hope you can understand. 0 comma minus 2, 0 comma minus 3, all will be there, all minus. So infinite elements will be there, right? Dot dot dot, then 0 1 also will be there. 0 comma 1, 0 comma, you don't have to write this. Okay, don't write in your answer this, I am just explaining what you have to write. I will show you directly. You just have to write this one, and if you want to show also, no problem. It's not that if you write this one the examiner will deduct your mark, they will not deduct. Okay, so dot dot dot, and then what about 1? 1, will it be related to any element? Yes. 1 minus 0, integer, right? 1 minus 1, integer. So 1 comma 0, 1 comma 1, 1 comma 2, dot dot dot, then 1 comma minus 1 also will be there, because 1 minus 1 how much? 1 minus minus 1 how much? Plus, it will be 0. 1 minus minus 1, minus plus, sorry, 2 it will be, right? So it will be 2. 2 is also integer, so this also will be there in the relation set. So in this way, infinite. What about 2? 2 also, if you subtract any element, this also will have image, this also will have, this also, all the element you think in this way will have image. So domain, what it is? You know, domain is nothing but collection of all first element of your relation set. So the element which is having image, those all element will be there in this set. So here what I can write? Can I write domain directly integer? Because all element will be there, right, in this set. So simply integer. What about range? Now in range also you can see all this element will be image of some element or not. You can check. 0 if you take will be image of many element, right? This also, this also, this also, it will be related to some element, right? All this element will be related to some element. So obviously your range also will be Z. Okay, if you haven't understand this one, let me know. Okay, so this is how you can write your last question. Okay, first you write down this one, given this, and then directly you can write domain, range, this one, and the diagram also you can show in exam, no problem. Okay, you don't have to show all the arrow mark here, just show some mark here. The examiner will understand that you have understood the problem. Okay, but try to understand this one carefully. If you have not understood, let me know. Okay, I will show you another example related to this only if you have problem here. Okay, so first thing, you try to analyze whatever I said here. Okay.